Good morning, children. So now we are going to discuss the topic as magnetic field and field lines. Students, we know that when we are considering the case of a bar magnet and in the case of a magnetic compass, suppose I am bringing a bar magnet near this magnetic compass. So you can see that this magnetic needle is showing deflection. You can see that this needle will show the deflection. So we can say that when we are bringing a bar magnet near this magnetic compass, this needle is showing deflection. Similarly, we can consider one more situation which you can observe that I have two bar magnets. Suppose I am bringing the same poles of these two bar magnets together. You can observe that both the poles are the same only. So I am bringing these poles together. You can observe that. So we know like poles will show a repulsion. So in this case, you can see that I don't feel any repulsion. But here onwards you see that they are running away. You can observe that they are going away from each other. That means they are showing repulsion. Here they are not experiencing any repulsion. Here also they are not experiencing repulsion. Here also. But here onwards you see that slight repulsion is experiencing. Here it is a more. So you see that. They will not come together, they are going away. That means this repulsion is experiencing in a certain region only. Similarly, I can consider a situation which I'll bring this unlike poles together. You can see that. One is a north and another is a south pole. If I am bringing, here there is no attraction and here also no attraction. But here onwards you see that there is a more attractive force is there. That means they will attract together. So you can observe that. That means this force of attraction is also experiencing in a certain region. So we can say that in both these situations we can say that this magnet is experiencing this force of attraction or a repulsion in a certain region only. So we call this region as a one name. So that is known as a magnetic field. Magnetic field. So we can say that magnetic field means it is a region around a magnet in which a force of attraction or a repulsion is experiencing. So that region around the magnet in which a force of attraction or a repulsion is experiencing is known as a magnetic field. So if you are considering the case of a bar magnet, like this if you are considering the case of a bar magnet, one is a north pole and another is a south pole. So we can say that the region around this magnet in which a force of attraction or a repulsion is experiencing, that is known as what is that? The magnetic field. Now we can consider one more situation which suppose we are having a bar magnet and I am sprinkling some iron filings over it. You can see that this type of a pattern is coming. You can see that. Have you seen that these iron filings are arranging in the curved pattern? You can observe that. So this curve patterns are representing the strength of this magnetic field. And this curve lines we can say that these are known as magnetic field lines. Magnetic field lines. So magnetic field lines are representing the strength of this magnet, we can say that. And you can observe that that is in the form of a curve lines only. So we can say that these magnetic field lines are starting from this north pole and terminating on the south pole outside the magnet. Like this we can representing the case of magnetic field lines. So magnetic field lines are representing the strength of this magnetic field, which is starting from this north pole and terminating on the south pole. And inside the magnet we can say that these field lines are from south to north. In this we can representing field lines inside these from south to north. So we can say that these magnetic field lines are continuous closed curves. Like this we are considered as a closed curves in the case of magnetic field lines. So this is the first property we can say that when we are considering the case of a magnetic field lines. So they are starting from north pole and terminating on the south, and inside it is from south to north. So magnetic field lines are the continuous closed curves. Now we can observe the case of a magnetic field. We can observe that Suppose if I am bringing these two magnets like this way, in this way you can observe that they will show the attraction. Suppose if I am bringing the two magnets like this way, you can see that immediately they will come to this way. That means this force experiencing is more at the poles. So the strength of the magnetic field is more at the poles. That is the reason we can say that the magnetic field lines are more crowded. You can observe that field lines are more crowded at these poles. So this is considered as the second property. We can say that the strength of the magnetic poles. That means the strength of the magnetic field is more at the poles. So in the previous activity also you can see that field lines are more crowded. You can observe that the field lines are, there is a more number of lines are there. Like this way. You can observe that. So that means this magnetic field strength is more at the poles. So this is considered as the second property we can say. And another property we can say that when we are concerned the case of a magnetic field lines like this way, you can see that the tangent which is drawn at any point gives the direction of a magnetic field lines. So the tangent which is drawn at any point gives the direction of a magnetic field lines. And one more property is that these field lines will never intersect. The magnetic field lines will never intersect. Why they will not intersect? Because suppose if we are considering a situation which any two field lines will intersect, and the magnetic needle at this point, if you are keeping a magnetic needle at this point, so it should show two directions. That is not possible. That means field lines will never intersect. So these are some of the characteristic properties of magnetic field lines. We can say that. So I said the case of a magnetic field, that means it is a region around a magnet in which a force of attraction or a repulsion is experiencing. So that region is known as a magnetic field. And we have seen the case of magnetic field lines also. So the strength of the magnetic field is represented with the help of imaginary lines, that is known as the magnetic field lines. And there are some of the properties also we have seen that they are starting from north, terminating on the south. And inside it is a south to north, so they are considered as a continuous closed curves only. And the second property, the strength of the magnetic field is more at the poles, and so field lines are more crowded. And third property we are seeing the tangent which is drawn at any point gives the direction of a magnetic field. And the fourth property is the two field lines will never intersect. If they will intersect, the magnetic needle at this point will show the two directions. That is not possible. So these are some of the characteristic properties of magnetic field lines.